Hello, my name is Tom Alcott, co-founder of BlockMark Technologies, and I'm here today to tell you a little bit about Registry, our platform for issuing, receiving and verifying certificates. In addition, I'm going to focus today on the blockchain aspect, which is an optional security measure to prove that certificates are untampered and immutable. Now, fake certificates make your business vulnerable, and by not having fake certificates, you can improve your reputation, save money and time. There's more information on our blog, but what I'd like to tell you about today is 3 characters who are using the blockchain backend to verify and make sure certificates are authentic. So we have Bob, who is going to issue a certificate to Alice, who's going to receive it, and Victor, who's going to verify it. Now, if we switch to Bob, you can see that Bob has his work account, and on his work account, he's already issued a certificate to Alice. So today we're going to focus on the ICVP, which is this one here, the certificate for vaccination that he issued to Alice on the 25th of November. Now, you can still see it's active. He hasn't suspended or revoked it here. And what we'll do is we'll go and visit Alice and see through the lens of her account what this blockchain log is about. So she has her ICVP, International Certificate for Vaccination and Prophylaxis. Quite hard to say. She has it in her dashboard with her other certificates, and you can see she keeps a log of them all there. So if we click through to the certificate, she has made it public over here. She can make it private if she wishes. Today we're going to look at the Ethereum blockchain log just here. Now, if you notice, certificate ID begins with 2D37. It's quite difficult to remember the whole string. That should be enough. So if we look at the Ethereum blockchain log, you can see the certificate data here, the way we prepare the data. You can see it's for Alice Jones, and it's that 2D37 there. Now, if I just focus in a little bit here on the hash, we've taken this data, we've run it through the SHA-256 algorithm, which stands for Secure Hashing Algorithm, and it's 256 bits, or otherwise 32 bytes, or 64 characters of hexadecimal. These 64 characters here are effectively a fingerprint of the above data. Now, that cannot be reverse engineered, so it's a one-way function. If you're interested on this hash 1C40, you can play around with it here. If I wanted to maybe change the data, you can change a single part of the data here. If I change Alice here to Andy, you'll see the hash, which begins 1C40 over here, will indeed change. So, Andy has changed the hash, and if I go back, you'll see if it's just Alice, that's the original data, 1C40. So that hash is unique to that data, and we're going to submit it to the blockchain, the Ethereum blockchain, and this is the transaction hash beginning at 6D4. Now, we can view all of the above on the Ethereum Explorer, which is called Etherscan, which is an audit tool, and we can see that the transaction hash of 0x6D4 with the smart contract, which is run by BlockMark Technologies here. If we look at this log of that transaction, we can indeed see the hash 1C40. So that data is timestamped on the blockchain forever. So it's anonymized, so it's all safe for Alice, and Bob can rest assured the data is there as well. If Alice wants to, she can download a receipt of that information and keep a copy in her filing cabinet along with a printed version, what we call cold storage. She wants to share that with Victor. Victor is the verifier. He's a professional verifier at events and venues, and he has a dashboard. He has his own personal account, but he has verified certificates here, and you can see the ICVP certificates that he's already verified, Alice Jones's certificate here. Now, if we view that inspection, you can see that the values are consistent when they were checked, and the current values, they haven't been revoked or suspended here. There is also the option to do forensic analysis by looking at the signatures and the private and public key data. So here's the original data again, the Alice Jones data, and here is a private key, which is like a PIN number that only BlockMark has, and here is our public address. Now, we use the PIN number to sign the document, and that is shared with the public address there. Now we can check all this using a verification signature tool. So this again is on Etherscan. So we type in our public address there, which anyone can see. We type in our signature, which only BlockMark can sign, because only we know the private key. And then we add the original data here to see if that is all consistent and has not been tampered with. This is a third-party tool, so anyone can check this. And then we press verify, and it does indeed check that the signature is consistent with the private key and the public address and the original data, and it's rubber stamped verified. So in summary, that is the blockchain backend for our BlockMark registry. If you want to find out any more, do please go to blockmarktech.com or contact us directly.